Chapter 3, Section 4, Metamorphic Rocks. So the formation of metamorphic rocks happens because metamorphism means to change form. So you need elevated temperatures and you need elevated pressures in order for this change to take place. All of these changes, or these temperatures and pressures, take place just a few kilometers below the Earth's surface, down into what we know as the uppermost mantle. There are a couple of different types of metamorphism. The first is contact metamorphism, and this is when you have magma that moves into pre-existing rock. So obviously you would need to be near a body of magma for contact metamorphism to occur. And these changes are driven by increased temperatures. We also have what's known as regional metamorphism, and this is a large area deformation. This is from pressure and high temperatures that occur during mountain building, so this is very specific, and it produces your greatest volume of metamorphic rock. So when I say mountain building, that means that's where you're going to find the most of your metamorphic rock, is in your mountains. And you can see several different types here. There are a few different agents of metamorphism. Heat is the first. It provides the energy that's needed for chemical reactions to take place, for the change to occur. And pressure is another. It causes more compact rock with a greater density to form. So very high pressure, very high temperature. And we have to have an origin for that pressure. So there's two different things that you see going on here. The first is a confining pressure, so it compacts everything in one direction. And then we have what's known as a differential or a deformed pressure, in which everything's being pushed together and causing this banded or layered appearance. Hydrothermal solutions is another way that we can have metamorphic rocks form. They're based off of hot water. That's what hydrothermal is. Hydro is the water portion. Thermal is the heat. And it escapes a mass of magma and then solidifies. So recrystallization is occurring here, and you're dissolving the original minerals and then you're depositing or creating new ones. So classification of metamorphic rocks, we have two categories. We have what's known as foliated and non-foliated. So looking at foliated first, we have a banded or layered appearance. So for example, gneiss. Gneiss has a banded appearance. So you can clearly see the different layers in the image. Non-foliated is just the opposite. There's not a banded texture for this one. Your example, marble. It looks very clear, very clean. You don't have those layers that separate it out. So looking at our image here, and this comes from your textbook again, we have our classification. We have foliated and we have non-foliated. So foliated's up here at the top, non-foliated's here at the bottom. And of course we still have a difference in grain size, and that's what's going to determine the type of rock it is. So gneiss is medium to coarse, so you can clearly see those different bands. Whereas in something such as slate, it's very fine, but it still has bands. It's just harder to see those bands. Then in our non-foliated, so those that are not banded, who doesn't have a layered appearance, marble, that's the medium to coarse, that's the one you can really see. And then we have anthracite, which is looks a lot like basalt, so it's very dark in color. And that's fine grained, but also still non-foliated. So for today, in your textbook, you need to read Chapter 3, Section 4 of the Earth book, then work on the metamorphic assignment and do the metamorphic rock lab. And that's it for today.